Thank you. Where am I? So this is you don't need this sentence. I guess we know they are calculated differently. I mean, you've explained how different they are.
Okay, I can
Uh,
get rid of it.
yeah. You could just, yes, this could be especially useful when there is still time to interview. This also is too philosophical.
Okay. I just kind of wanted to bring up the idea of using this too for this cohort, this TCGA cohort that has primary sections, but I can also get rid of it.
So this is telling, you know, what the role of biomarker is. So maybe you describe the clinical implication of TMB, and then you describe the clinical implication of ITH.
Yeah.
And then I think you need a paragraph to say neither one is, you know, perfect. They have big limitations. But if you use them together to better assess molecular traits and better and use that combined biomarker to better select the best next treatment, you know, that will be you know, major advance in the field.
Okay.
Something like that. And so that's our logic why we're looking at both simultaneously, because we believe looking at those together will help us predict better prognosis, better better utility in selecting the right treatment.
Okay.
So yeah, in that context, write something, and then so why did you put this 994?
I kind of just wanted to cite that just because there's just cite some evidence regarding early stage patients and really show that just because you're early stage doesn't mean that you're going to get cured, that there's still a pretty high recurrence rate.
So it's really vague when you say early. Is it 1 or 2 or 1 and 2? So you have to be very specific, but also avoid using the exact numbers in introduction. It becomes like it's the same thing, same theme, becomes too heavy. Introduction is more explaining the concept.
Okay.
So for your paper, what is TMB? What is ITH? What are the clinical implications? What are the clinical limitations? And why do we need both? And what actually did we do to tackle that issue? So we went to TCGH that has this number of patients, and we looked at ITH through different methods, and we looked at its you know, how the landscape and how it affected survival. Yeah. So
you're saying add another paragraph about like what we're doing specifically.
Yeah.
Okay.
So in the introduction, because it's the original paper,
right?
So what's the status, you know, current status, and where should we go? A better biomarker. What is the current knowledge gap? There really hasn't been many papers, you know, addressing ITH and TMB and its clinical impact. And the papers that looked at it didn't really find much. And their sample size were small, whatever you want to say.
Yeah.
And not citing any numbers. You cite all the numbers in the discussion. And then and always end these papers, and this is like writing introduction. scientific writing 101 for all of you here, is that what's my hypothesis? I believe if you combine both, my hypothesis is that if you combine both, you will be better, you'll be able to better prognosticate.
Okay.
At least for this paper, because you're not doing any predictive biomarker, you're not, there's no therapy involved this.
Yeah.
You there, and then you also claim that the association between the two, histology plays a role in better, I guess, histology is an interacting factor or whatever, there's an interactant between the histology and those associations. That's your hypothesis, and you use this data set to explore the landscape and association. So yeah.
Okay.
So
That's helpful.
yeah, that structure is kind of missing. So and then move a lot of those detailed discussion to discussion. So same thing, what non-small cell and what is number of patients.
Okay.
Kaplan-Meier is K and M, capital letters. Here I would say how many are squamous, how many are non-squamous, and
that makes sense. I mean, I have like a demographics chart a little later, but I can include that there as well.
Okay, early stage. And you have stage 1 to break down here.
I just included the early stage, but
because that's what we did, right? We didn't look at the stage.
But I talk about this in the discussion. I guess I should have put like the figures and table section somewhere else. It was more for my for easy reference.
Yeah, but when you actually submit it, you can put it after referenced. So you get rid of the background color, and then just add a footnote describing. So I know you put like what is it's going this the acronym, but you always explain it one more time here. Same thing, MB is megabyte or things like that. OS, PFS, TMB, still write it out all.
Yeah, I'll put it in the footnote.
Yeah. So here there's, I guess, the sex difference here, and everything else looks okay. Stage 1 is more common.
Yeah, it's interesting. It seems like squamous cell is more often diagnosed at stage 2, while adeno is more often diagnosed at stage 1. I talk a little bit about that in the discussion. I thought it's worth mentioning, but
yeah, but it could also be random,
right?
How they collected. So here, I guess this is.
So first I looked at just TMB and just ITH, and then I combined them just to show the relationship in general.
High, low.
And so one thing I forgot to mention is that originally when we were selecting cutoffs, I was selecting them based on kind of the p-value. I was picking them that way. I found this package that was used in a lot of biomarker papers called MaxStat, and it pretty much does the same thing with a little bit more statistics behind it. And it seems like it's been used in a lot of places. So that's kind of what I'm relying on for the cutoff selection now.
So when you say p-value, does it find a cutoff that gives you lowest p-value? Is that?
So if you go back up to the methods, and you go to cutoff selection, there's this package called MaxStat. It's an R package that's been used in a lot of papers for molecular biomarkers. And it pretty much does the same thing where it looks at all the cutoffs and picks the one that is kind of statistically most significant. And that doesn't necessarily mean the lowest p-value. It's kind of the lowest p-value, the sample size, and that sort of thing.
Mm.
So it's similar to what I was doing before. It's just a little bit more, I think, substantiated in the literature.
Okay, so it's 3.37. So I think people would like to know how TMB and ITH is distributed. So maybe just a distribution graph for both.
Okay.
I would say do that for each squamous and adeno, because that's how you analyze.
Yeah.
And you can put that in supplemental figure.
Okay.
That way people know where the median is, how
Right.
it's distributed. Okay, but anyway, TMB does have prognostic impact in early
Squamous.
stage squamous, but adeno it does not have any. Well, no, it's both. And then
I don't know. It doesn't.
what is adeno? So
Oh,
this,
I think that's just a typo.
which one's adeno?
Oh, the bottom one. It says ITH, but that should be TMB.
Okay, this is TMB.
Yeah, sorry about that. That's just a typo. I'll fix that.
Oh, okay. Both are the four graphs are all TMB.
Yeah.
Okay, so in adeno, no TMB impact. Okay, which is very interesting.
Yeah.
And then you go to ITH. So squamous ITH, high ITH is better. High ITH is better. And then adeno, low ITH is better.
Yep.
Yeah, it's clear. Now it gets complicated. We do
Yeah.
both at the same time.
I have a little chart with the cutoffs that I tried. And
But
basically there was only
how
one.
did you select? Now
if-
you have 10 and 1.5
Right.
versus
Right. So
you kept
it's-
1.5 here.
right. So if you scroll down to the supplemental, there's a figure there that has a short little list of my cutoffs. Scroll up. Yeah, right there. It
Uh-huh.
just got separated by the page break. So the way I was doing is I first tried the cutoff that I got for just TMB and just ITH.
Uh-huh.
And then just TMB. And then based on that new grouping, I then selected using this max stat, I selected a cutoff for that group. And so there's really two pairs of cutoffs. There's the 3.37, which is kind of what I used for TMB originally, and one, which is what max stat selected. That wasn't statistically significant. But interestingly, what was ultimately statistically significant is using 10 as the cutoff, which is the FDA cutoff, and then using 1.45.
Now, how did you get 1.45?
Again, through max stat. I divided the groups based on TMB, and then I took the low TMB group and kind of plugged it into this algorithm, and this is the cutoff that it selected based on sample sizes and p-value.
Okay. So 10 was chosen as a clinical cutoff. So you
Correct.
just decided, yeah. So I think you need to explain that in methods.
Well, I mean, I talk about it in the discussion. I don't know if I need a separate kind of, I'll have a footnote.
It's method. So for TMB only and ITH only, you kind of picked.
Okay, I can flesh that out.
Yeah, so you describe that in the methods, not in discussion.
Okay.
And then say for when you were looking at like a 2x2, 4 different groups.
Yeah.
You intentionally selected 10 because it's a well-known clinical cutoff.
Yeah.
And then for ITH, you use the program to get 1.5.
Right.
So yeah, describe that so that people know what you did, and
Okay.
then this is how two groups are divided: low
Mhm.
TMB, high ITH,
Yep.
and low TMB, low ITH. Okay. Okay, I'll go up again. So we're looking at only low TMB here,
Correct.
and then in squamous, PFS, high ITH. High ITH is better prognosis.
Yep.
In adeno, low TMB, high ITH is detrimental. I guess OS there's a trend.
Yeah.
Yeah.
OS, yeah, there's the trend, but OS is tough because it really just depends on what medications they received
Hmm.
and how they were followed up. So that complicates it a little bit.
Yeah. So I'm looking at the, and this is opposite. This is how adeno and squamous are biologically
Yeah.
very different. Now, I remember giving you comment that there's a lot higher number of drivers like EGFR,
Yeah.
and
So I
we
looked at that. We have a
yeah,
driver. I have a driver's section.
where's
It's in supplemental.
is it down or you
It's
oh,
in the supplemental. So if you go into, there's like a supplemental figure section. Yeah,
where
scroll up right there.
oh
The
here
fourth one, yeah. So I used a package that kind of just predicts what these are based on how many mutations are located, how much kind of selection is happening
uh-huh.
in these mutations. And so this is what that algorithm spit out. And then I also included a little bit of kind of significance of these genes. Some genes don't really have a significance, a known significance, others do. So for example, adeno, like you were saying, has a lot of drivers, and that's what this algorithm showed: EGFR, BRAF, KRAS.
Is it are you describing in order of frequency or just random order?
Well, the order is kind of in the order of significance, but they're all very close.
Uh-huh.
Um,
What do you
I
mean?
can include the p-values from the what the algorithm spits out.
Mhm.
But these are just basically the top ones, basically the only ones of the list that are statistically significant and aren't random.
So how do you decide the p-value from this program? Like what are you
Oh, the way that it's called, if you go to methods, there's I talk about it there.
Mhm.
Driver gene. So I use this OncoDrive Clust package in R. And the way it works is it looks at all the mutations across all the genes and tries to see if there's kind of selective pressure in any specific gene based on the number of mutations, the types of mutations, whether they're synonymous or non-synonymous. And then based on that, it decides if this is kind of random or if there is a selective pressure and assigns a p-value to it. And
So
then if
the input from TCGA is actually the DNA sequencing
correct.
file for each patient. Do you compare two groups or is it just within that group?
It's just within that group.
Okay, so just I guess just running through the known driver information in the program and just extract that information. Right?
Yeah.
Yeah.
So to that figure, I can add the p-values.
Yeah, and describe what that p-value is coming from in
In the
the
methods, I'll
yeah.
describe it.
Like, people are not familiar with the program,
Right,
so you have to explain what the program is doing.
right.
So my suggestion is I like this, but this is all within this group. And people want to know the frequency, this group has how many number of patients, and then how many number of patients actually had this.
Okay, I can add that as
patient.
well.
The number of patients with frequency, and maybe not the p-value, but I would arrange this in the order of frequency.
Okay,
Yeah. Now so in adeno, whether it's high ITH or low ITH, you have EGFR here.
correct.
So, and EGFR seems to be the only one in high ITH. It's very interesting.
Yeah. And that just could be sample size.
Yeah.
The sample size for this group is kind of on the smaller side.
I see.
Because I picked such a low TMB value, there's just like there's less patients with that, such a low TMB.
Yeah. So I think the reviewers will say, is that the effect of EGFR containing patients or not? So whether this graph, what is the role of EGFR on this graph?
Yeah.
So do one with EGFR, do one without EGFR?
So
and see-
remove patients. So you're saying remove patients who have EGFR mutations.
Right, and see if
Okay.
this still holds true.
Okay.
And I think maybe like 20% of them will be EGFR, something like that. And you can, yeah, I think EGFR were present on both groups, high and low TM, low
Yeah.
IT. So, so all low TM. So, did we decide to just not discuss high TMB?
Yeah, I thought that would make it simpler. As far as the cutoff selection goes, the discussion, I feel like if we include high TMB, it's another pair of groups. I feel like it makes it a lot more complicated and it's harder to get the message across. I
So
don't know.
here, look at the squamous. You have TMB less than 10.
Mm-hmm.
And then underneath adeno, you have TMB less than 1.9.
Correct.
So explain why you did it this way.
Right. That kind of goes back to what we talked about regarding the cutoff selection.
Mhm.
So I'll include that in the methods,
Mhm.
and hopefully that will be clear.
So
Or do you mean describe it from a different
yeah, because I think
perspective?
the reviewer's question is gonna be, we understand that squamous adeno are different, but using different cutoff for different histology will sort of make the reviewers think like, are you always changing the data cutoff to make,
Right.
to bring out only the changes, significant changes. I think, I mean, I'm not opposed to it, but
But I understand your point. So maybe that's where the distribution comes in. If I can show that the distribution of TMB across squamous versus adeno is different, maybe that will be helpful.
yeah,
Which it's not statistically different, but there is definitely, like, if you look at the table 1 in figures, the mean is different. There's definitely differences in the range and in the quartiles. Squamous cell does seem to have a slightly higher a slightly higher range, but a lower mean. I don't know.
So,
It is a good point. I don't know how to tackle that.
yeah. So for these analysis, I'll say it in the method that for different histologies, you decide to use different cutoff. I know you. Well, here you. So my concern is you decided to have 10 cutoff for TMB when you looked at squamous, but you didn't do that for adeno.
Well, I mean, I didn't. I tried it, but it wasn't statistically significant. So,
So how did you get 1.9? Did you
so
just select it?
yeah, so for 1.9, I plugged all these samples into MaxStat, and that was the cutoff it selected for TMB. And then I used that cutoff to create a low TMB group, and then I put that group into MaxStat, and it said, okay, for that group, 2.89 is what it selected for ITH.
Hmm. So I think it has to be consistent. Both you can't put 10 for squamous and adeno 1.9 that came out from previous just the like the TMB only analysis, right? So
Yeah,
it has to be. I guess you have to show it. Like when you have 10, adeno does not show any difference.
okay, I can do that.
And you can put that in
Supplemental.
supplemental figure. You have to just be consistent in what you do.
Okay.
And then same thing, if you do squamous, if you pick 1.9, where I think for
Yeah,
squamous it was 1.4,
right.
or no. TMB was what?
3.37.
So if you choose 3.37, then you might not get pretty graph like this.
Yeah.
Still, you have to be consistent. So why don't you do it both ways? But then you can still pick and choose the one that has significant, and then you don't have to put the cutoffs here.
Just put them in the footnote.
Just put them in the footnote so
Okay.
that people kind of get the concept, and then yeah, refer to the supplemental figure for this cutoff with this histology or something, so that they can
Okay.
look at those. But this is really just getting to the concept that how ITH and TMB plays a different role in two different histologies.
Yeah.
Um,
Okay.
and
That makes sense.
do the same thing for with and without EGFR.
Okay.
And I guess if you remember the cell paper, the immunotherapy works better when if ITH is higher. Remember that paper that showed with the cell lines?
The ones where they went back, or no, I don't remember. I'll probably.
It's the Charlie Swanton's paper. He was part of it, but it showed preclinically with the cell lines that if you
Oh, the mouse lines. Right.
yeah, the mouse, if you create different clone, then somehow the T cells will recognize them better with more antigens,
That makes sense.
and then the immunotherapy works better. So it doesn't have to be immunotherapy. It can be your immune system
Right.
that does the surveillance, but you see many different antigens, and there you go. You got you got it sensitized, and they are immune surveillanced.
Yeah.
So the better prognosis. So the squamous cell lung cancer follows that story where better immune system. Well, I guess heterogeneous tumor,
Yeah.
higher pH has better prognosis, and this is in the absence of what we call oncogenic drivers that in terms of oncogene addiction.
Mm-hmm.
the drivers that you mentioned there below for squamous cell are not traditionally considered
Correct.
drivers,
Yeah.
but still, according to the program, they were, they were what came out, but none of them had EGFR KRAS or anything like that.
Yeah.
So I think that's a good contrast. But in the setting of many oncogenic drivers, then we think those drivers are, if you have it, you don't need many more mutations to metastasize, or
Yeah.
you have enough mutation already. So you having low ITH here is this group will contain more drivers. That's my point. Because
Yeah.
you don't necessarily need more mutation to get aggressive. And this in low TMB group are the ones with, let's say if you have driver, what happens if you have more mutation? A lot of those new mutations will make tumor more aggressive and
Yeah.
more resistant to targeted therapies. But if you select out only low TMB group, your chance of having that bad mutations, resistant mutations, gonna be low. So if you select out only the low TMB group, within that group, if you look at low ITH,
Mm-hmm.
which means more so that you have, a driver mutation, versus high ITH, your prognosis is better if you have early stage disease.
Yeah.
It's really hard to put it into, a clinical perspective. But anyway, I mean,
I guess clinically, my thought was that,
Uh-huh.
if you have someone who is an early stage patient, they have a resection, you're able to determine from that resected tissue, you're able to determine a TMB and an ITH. You can use that to decide, does this individual need more aggressive treatment, more aggressive adjuvant? What's the risk that this patient is going to have a recurrence? That was like kind of my understanding of a clinical application of this, but
Mm. So high ITH is bad in adeno, but this is only for low TMB.
correct.
So I feel like the reviewers would want to know what happens in high TMB. I mean, I didn't think we saw any meaningful reverse association like this, but I think we have to put that in supplemental figure.
Okay. And I would use these same cutoffs
Yeah.
for
So
that.
same cutoffs. So one clinical, one program based. Yeah. So let's do
Okay.
that. So in squamous, is this first one squamous? Yeah.
Correct. Yeah. So I used single sample gene set enrichment analysis for this. And these were the 4 groups or the 4 subtypes that were statistically different between the high ITH and the low ITH groups. And so what we're seeing here is that in the group that performed better, we have more memory B cells, we have more type 2 helper T cells. And then in the lower, the worst performing group, we have more Tregs.
So this kind of fits the story.
Right.
Or in
adeno, in adeno, there's also 4 groups. But what I think is really interesting is that B cells, again, are higher in the better performing group.
Hmm.
And so are macrophages, for example, but that wasn't. Um, Yeah.
Significant. Hmm.
no, it was statistically significant. It just wasn't, it's interesting. What I think is interesting that in squamous cell, the better performing group had more B cells, and then in adeno, the better performing group had more B cells, but the two groups are switched.
Yeah. So it fits the story. Yeah.
Yeah. And then there's these other two subtypes that aren't as well studied that I included just because they were significant. Yeah.
Hmm. Yeah. Some of this has to go to the method.
Yeah.
Same thing. Some of this goes to method.
Yeah. That makes sense.
Same thing.
Yeah.
So how you did the analysis, some of this will go to method. Same thing, yeah.
Yeah.
I think these are all more methods. And
And
then
that's a paragraph I need to write about Lunit scope and EMT score.
sure. So the my suggestion is
Well, the demographics section, I feel like is mostly this, there's not as much method stuff in the discussion in the demographic section. But anyway, sorry, continue.
yeah. So you have method. So method has to have a lot of references. So
Right.
this is how we did it. And then so similar papers that use the same method, you put the reference there. And then you have section, not discussion, you have results. Results will have a subheading that shows what we found. TMB,
I can do that.
ITH distributions were different by histology, and just show that. Next, TMB had I guess differential survival outcome in both histologies. ITH, same thing. So under each heading, describe what you found and put, the relevant table and figure in parentheses for all that. So don't discuss anything about what others did, or don't describe anything about the method. So strictly method is in method section. Outcome, just the outcome, the numbers and the p-values.
Okay.
Just strictly what we found goes to the result section. Now don't describe anything about what it means. In the discussion is where you go through each theme. Like, this is what we saw, and this is what it means. And then always, what did the literature show
Right.
in this topic, and what is consistent with our finding, or what our findings, why our findings are new and noteworthy. And then the limitation and future directions, that's the discussion. So
Okay.
have that structure ready in your mind when you
Yeah.
write.
Yeah. I can do that. I can set that up.
Yeah. So yeah, nice start. But yeah, this is deep. So
Yeah.
I'm looking at this with the reviewer's eyes. They're
Right.
like,
No, this is great.
what did you actually do? Like,
Yeah.
so you have to present it in a way that people who doesn't know, who had no idea of what ITH and TMB is, you just have to start from the beginning, and let them really follow you and understand everything. Don't assume they know things. Okay, very good.
Yeah. That was great. Thank you very much.
No problem. So Stas, also let's work with, so I need to get the Guardant's
Right.
data. I think Liam, work with Firas to get the Guardant BAM file. So with that, you can you can run PyClone.
Well, I
that-
need to process it a little bit.
Yeah,
I remember we were talking about getting a VCF file. I don't know if that
right.
was,
I think that's possible too.
because that would save me some time and a lot of steps.
So Liam, let's work on that. I think Firas is the one who has the key. Garden's saying they already gave everything to Firas, and it's so we just need to find a way to get the data from him and then have Stas run those heterogeneity analysis, and then the Tempest, for all the Tempest patients from our cancer center, I want Liam and Stas to have access to both DNA and RNA sequences.
Yeah, and we have that. We have that access. Yeah, we have copy number, we have mutations, and then we have RNA-seq.
So yeah, so that's from the tissue. I know they have liquid, but I don't use them. They are not less
Right.
sensitive than Garden. So so the grand picture is for the ones that we have both Tempest and blood, we want to be able to look at both ITH in the tissue from Tempest and from Garden, and really explore that landscape in stage 4 patients and how that impacts our own patients who received immunotherapy.
Right.
So that's where we want to get to. So we'll keep on, analyzing them. But this is a nice start, but yeah.
It's just, it's, one complicating factor is the fact that some patients have this data before they're or rather they have this data when they're treatment naive, and then other patients don't. And so I think that's also kind of another dimension that we'll have to explore.
Yeah. I know we're limiting ourselves, but we have to look at treatment naive.
Yeah, no, I totally agree.
Well, once we learn everything about that, then we can look to see how the clone changes on treatment. And that's another project that, yeah.
It's also just going to take a lot of, when I started doing this last year, it's really chart review heavy, to figure out which patients are treatment naive, and if they're not, what did they take? And, even as simple as figuring out which subtype, what histological subtype they have takes some time. So
yeah,
just to keep that in mind.
Yeah. So I think this year we'll have a lot of clinical help. And I know some of the clinical people and some of the students are coming to my lab. So I think we'll just have a big team, like the clinical digging and who loves running programs like you that, just work with you to, divide and conquer. I think, yeah, we're going to have to start there. And my goal is really, so Tempest, not just the Northwestern data, we can access the whole Tempest company data. And sometimes they won't, it's a big amount of data. So we might have to just work with their biostatistics people. But we will, because we've dealt with our own data, we can tell them exactly what they need to do.
Right.
And I think that's going to be a really high impact paper, because larger the data, better we are able to. And they do the text mining to see who received the immunotherapy and then what the PFS.
Oh, that's helpful.
It's really broad. It's not as accurate as the actual protocol, but they do that. It's AI based text mining, and yeah, that's all in the works. But the initial project with the mucinous, non-mucinous, so we're still trying to get that data. So Liam, follow up with them, because I think we're kind of put on hold for that. Just taking too long. I think we brought it up in last AACR and then they have not made any progress.
Was this a Tempest or Garden?
This is Tempest, mucinous, non-mucinous, Kevin.
So that one, they did get back to us and they said they can share more updates with us at our next TC.
I know they've been doing that. They just need to give us access. Like, I don't know why they're doing like. And then update, I think they were saying, oh, we're in the process of reviewing. You know what I mean? I don't know what the update is, but that's what they've been telling us.
Stas, were you included in that email thread with Tempest for this particular project?
No, I wasn't.
So maybe invite, yeah, Stas as well.
Yeah, I'm happy to help in any way I can. So what is I guess my question is, what's the issue? Because I know that in the Tempest bucket, the S3 bucket, there's pretty much everything. So I imagine that mucinous and non-mucinous are included in that.
Oh, no. This is the whole Tempest data project. So this, they will give us access. I don't know how they will give us access to their whole, because if it's not like they're giving us access to their whole like mucinous data, because we have to compare to non-mucinous. That means their whole non-small cell lung cancer database, which is a lot. So
I see.
I
Okay.
think it's more like if we give them like unbiased heat map or PCA analysis, then work with that data or something. But RNA, we can do the raw data analysis. But RNA level, we can still do that. So just the logistics of how we can have access to it, or who's going to be their point of contact stat wise, and work with that person.
So I guess that means that these subtypes are not included in the S3 bucket that they gave us access to. Is that correct?
Right. So this is
Okay.
more like their company-wide.
Oh, they're company-wide. Okay.
Yeah.
Not Northwestern-wide. Okay.
Right.
Dr. Che, if I may, I'm just going to quickly share a screen to show you the email from Tempest. So they're telling us the project has received full approval. So it's this email right here. We got it on the 6th, so just a couple of days ago.
Okay.
So this is the pulmonary invasive mucinous adenocarcinoma comprehensive molecular and clinical pathologic analysis. It says that it has received full approval, and they sent us a draft agreement for you to review and sign. But it's going to need to be signed from the institutional representative. And then, yeah, that's the next one. And then they can do the resource allocation and then move on with the project. And then with regards to the heterogeneity index validation, they met with met with their internal team. They are interested in discussing the idea. So we had this meeting scheduled so that their team and we can hop on a call and discuss this more.
So for both, Stas, you're welcome to join.
Yeah.
The 31st has been moved. We're in the process of moving that one. Yeah. So two different things, but whatever algorithm we kind of play with and decide to use for our own database, I want to apply it with the whole company-wide data set and see what the performance looks like. We kind of want to develop this together with the company. So that's the latter one. That the first one is really the first project we launched. So maybe Liam, after this Zoom meeting, let's come and sign and have let's work on that agreement thing together.
So does this need to be so it needs to be acknowledged by you, but it also needs to go into the contracting office, right? Okay. So I guess this should go to Adam.
You might have to, but this is really just I don't know. Yeah, does it say institution?
Yeah, that's what they said in the email.
Institutional representative.
Signature from institutional representative.
Sometimes it could be me, because I'm doing the project. It doesn't have. Because it doesn't require our IRB, or like it's not, it's their data.
Mhm.
I think I can sign this.
Okay.
Read and acknowledged. So maybe just email Jen Godin saying,
Mhm.
that, can Dr. Che be the institution representative?
Okay.
Or do you want someone else? If they say someone else, we'll just send it to, is it Adam? Or yeah,
Yeah. Okay. All right.
okay, let's do that.
And just FYI, Stas, I'll send this forward this email to you as well.
Okay,
Yeah. Thank you, Liam.
Mhm.
all right, very good.
Oh, and one more thing, Dr. Chi. So for the Guardant files, we should request access to the files for Stas as well, right?
Yeah,
Okay. So I'll send you another email regarding that to Stas. We've been trying to get that access with Dr. Firas on our end.
Perfect. Yeah, thank you. I did have one last question regarding the
Uh-huh.
Tempest patients.
uh-huh.
What do we need to do on the IRB side to cover that?
I think, Liam, we have a retrospective lung cancer protocol already.
Yeah, so that should be already covered.
Okay.
If you need the IRB information, you can just reach out to me. I can send it to
Okay,
you.
perfect. Yeah, I was just making sure.
Just add Stas as a personnel under that.
Sure.
I think he might be already added.
I think so.
Yeah,
Cool. Thank you.
great, thank you. All right, who wants to go next? Richard, you want to go next?
Yeah, sure. I don't have too many updates, but
Huh.
I wanted to show you the updated draft of that abstract for AACR because it's due, I think, the day after tomorrow. So here, the people at Bristol Myers Squibb, they got back.
Uh-huh.
A few edits that I wanted to go over with you before you submit.
Yeah,
And also I added this part in the results about the one patient who had stable disease at the end of the trial.
having continued stable disease at the time of the trial conclusion.
Does that sound okay?
Mm-hmm.
Okay. So I made a few changes. One main one was they wanted to either include 6-month PFS and IPFS data for the ACC cohort 2 or delete both of them. And we're a bit over word count. Is it okay if I take this part out?
It's, you're saying. Wait,
Like,
it's over the limit if you include that sentence?
yeah.
Then it's okay.
Okay, take out. Okay.
Yeah, for that, it is just the abstract.
Okay.
But for actual paper, I think it's good to, actual paper abstract, it's good to write it.
Okay. And then
Can you show me the title? I just wanna, for the people who are,
yeah.
the list. This is a phase 2 study that we ran here in our institution. The Nivo PD-1 inhibitor, a BCTLA4 inhibitor combined for the recurrent metastatic adenoid cystic carcinoma. It's a rare tumor, but it can happen in any tumor site. And you did you put site of origin data here?
Site of origin data, I asked them So they sent a spreadsheet, but it had the wrong information. So
Oh, that's why you're going chart by chart to figure out?
yeah, so I'm going chart by chart. I asked them if they have like data. I don't know. They haven't gone back yet about that, but I did like about half of them. Mostly salivary, like parotid gland
Mhm.
origin
Okay.
for ACC.
Yeah, and then if it's salivary and if you can sort of identify whether it's a parotid versus submandibular, you know, if you sometimes you don't know, not documented, but if it is, you know, enlarged from the CT scan, then you know that there you go, you have the primary site there.
Yeah.
So I think reviewers will ask where, you know, you're saying different anatomic primary sites, but what are those and what are their distributions? So yeah, that's actually for your actual manuscript. Yeah.
Oh yeah. I'll make sure to put it in the demographic table.
Mhm.
Okay. And then oh yeah, one thing about the conclusion I wanted to check in with you about was they didn't like how we wrote down like modest and moderate disease control
Huh?
because of the 4% overall response rate or 5%
Uh-huh.
one PR. And then they wanted to focus on the median OS, PFS, and disease control rate.
Uh-huh.
How do you think we should rephrase that then?
So is this a BMS reviewer?
Yeah.
Or- okay. But they suggested to focus on the delete response rate.
Yeah, they didn't like because they said it was like not great, I think. So yeah.
I get I don't know if they'll be I'm okay with taking that out. I mean, we already said 5% up there, so we don't have to write that here. But resulted in what do you think they'll think about the word moderate? Moderate disease control? What was it? Disease control rate?
Disease control rate was about 40% in the salivary neoplasm group and 53% in the ACC group.
It's decent.
You should delete that.
Yeah. I mean, survival and PFS for adenoid cystic is tough because they can be very slow growing.
Yeah.
And especially it's a very it's not an ideal endpoint when you don't have control. You're not, you know, treatment group and non-treatment group, you can't compare that. So you don't know if you selected for, you know, group of patients who have, you know, good prognostic factors. You know what I mean? So there's huge bias if you say that. I'm actually just happy with that. This is control and leave it as it
Okay.
is.
Okay, yeah, I'm fine with that too. Should I aim to submit today then? Should I turn it in?
Yeah.
Okay.
But you have to give it a BMS and authors. This is the final version we are submitting today.
Yeah.
And just kind of if they have any last minute like update, they will email you.
Okay.
I guess the deadline is day after tomorrow, so you could You could send that all, all the authors in BMS today and then submit tomorrow, because you still have 1 day as your backup.
Mhm.
That, yeah. So here, the other thing is for conclusion, you're saying ACC, but you have a non-ACC cohort too. And their disease control rate is not that much different, right?
Yeah, 40%. Yeah.
Yeah.
Okay, I'll
So then
add.
you probably have to say both, right?
Mhm, with both. And other salivary gland neoplasms.
Yeah. I think that's fine.
Okay.
Yeah.
Okay, cool. I'll send that today. And then I don't have too many updates on the manuscript. I'm working on the conclusion right now. I haven't had too much time for it. I could just show it like when I finish it instead, maybe next week.
Yeah.
Okay. And then besides that, that's all for me, really.
Okay, sounds good. So let's submit and, oh, I don't know if it's only for the first authors, but see if there's any treble award. You can put yourself as a presenter.
Yeah.
Wait, this is clinical trial, so because you're not the PI, I don't think you should be the presenter. You can. So let's do this. Put yourself as a presenter and submit. If it's a poster, you should just present it. It's okay. If it gets a like oral presentation, I think the competition is too fierce. I don't think we'll get oral. If it gets it, because I am the PI, I have to present it. That's kind of the BMS and Northwestern agreement. So if it gets the oral, I'll present. But if it's a poster, I don't think they'll pay much attention to who present it, but it will be good for your career, like presenting like the trial result in a national meeting. So you should just present. That's just
Okay.
that. Yeah.
Yeah. And then is there any submission fee or anything like that?
I don't know. Do you know, Liam?
Yeah, there is. Richard, you can reach out to me. This one will be coming out of Dr. Chia's research funds.
Okay, I'll reach
So yeah,
out.
we can sort it out.
Yeah. So Liam will pay with my credit card, and then you just send us the receipt. That's how it's gonna work.
Oh, okay, I send you a receipt for reimbursement, kind of.
Yeah, but you have to use my credit card. You can't use
Oh, I see. Okay.
the credit
Yeah,
card.
just for records.
Yeah, has to be my name. So
Okay. Yeah, I'll do that.
yeah. Anything else?
No, that's it for me for today.
Okay, great. Great. Okay. I know Eugene is connecting from Korea, but Maddie, welcome, Maddie.
Hi.
Hi.
Thank you.
Do you have an appointment with me scheduled, or?
Yes.
Okay, good. And did I tell you about a potential project?
Yes, you did.
Can you remind me what that was?
Yeah, it was the oncocyte mRNA signature to predict immunotherapy response is what you were thinking.
And so this is something that you can work with STAS as well, because so I'll tell you so that everyone understand what this project is about. So Oncocyte is a company that we're collaborating with, and they have developed, and there's nothing new, developed mRNA-based signature that predicts who will respond better to immunotherapy. So it's very basic, and it's just based on the not mutation, but really just transcriptomic profiling.
Okay,
And they used AI, artificial intelligence, to sort of get the right mix. And they claim that it works for different solid tumors, but for lung cancer, we have clinical annotation of patients who received immunotherapy, and Jisang has the radiomics data, and a lot of those patients received immunotherapy, and we have the clinical outcome. So, Maddie, you should be working with Jisang,
okay,
who has the clinical annotation, and then Stats has access to the Tempest mRNA sequencing, the raw file. So there's a lot of logistics involved here. And we, of course, there's a lot of, let's say, shared algorithm for these signatures. So we can look at those different signatures. There's one called TIDE, TIDE. But there's a lot of known immune signatures. Some just use CD8, interferon gamma, and perforin. I think, cytotoxic T cell, if those were highly expressed, then you know that T cell is really active. But that's sort of like more like elementary level. But I think Oncocyte is really claiming that they have really superior algorithm, and it's black box, and it's protected by their patent or something. Like, so we don't know exactly what their algorithm is.
Mhm.
But if you go to the homepage of that company, Oncocyte, so they have two products. One is liquid biopsy, one is just a tissue-based, RNA-based predictor. And they're looking into different histologies. So I think you should start reading about what their signature looks like and what their data is in lung, bladder. They have one in their, breast or some, and what our agreement is, if we give them access to our Tempest raw data, like mRNA data, of course, de-identified, they'll be able to just generate us by, just good response, refractory,
Okay,
yes or no. And we're just going to have to correlate that with our clinical outcome, response rate, progression-free survival, overall survival.
okay,
A very clean project. We just have to figure out way to give them access to this RNA data. So Stas, why don't you work with Maddie and Liam? You know the Oncocyte contacts, so work with them to see how we can move forward.
okay,
And we have like the MTA that covers Northwestern and Oncocyte. And it's not just the liquid, but the tissue is also, I think, covered under that MTA or something. And it's not like we're sending any samples. We have, so the Tempest is not involved. Tempest think the RNA data belongs to the researcher. So once we have data from Tempest, it's our data. Because it's de-identified, we don't need any patient consent, and this could be covered under that retrospective lung, this biomarker analysis.
okay,
So I think it's feasible, and Liam, you can add Maddie under that as a study personnel for that IRB too. So yeah, we'll talk more about it when you visit our lab.
okay, yeah, sounds good. I have the meeting scheduled for Tuesday, the 24th.
Okay, so
So,
we'll talk more in detail, but in the meantime, we can kind of work on how, getting the data access.
okay, sounds good.
Okay. All right, Stas, you'll be able to help her and yeah, would be nice collaboration. I mean, we'll look at our own signature, but I think I want to see how the OncoSci, because their data is too good to be true. So we gotta validate with our own patient data. So let's do that. Okay, good. Any questions, Maddie?
I don't think right now.
Okay, good. Thank you. Okay. Eugene, I know you're late night.
Thank you.
Over there, I'll let you go first.
Okay. Yeah, I only have an update for HPD project, so I will share. Mm. You probably see the screen that I shared, right?
Yeah.
Oh, can you see the, yeah, okay. So from the last week, like we detected so many errors of our data, especially for the progression, who got progression, and Arnie checked each single data again, and she collected the new, like the sum of new lesions as well. So I performed another analysis on the data, and I'll show the results. So this is the final, I mean, the incidence, and among like 120 or 136 patients or regimen numbers, about this percent was detected as having progression on their first post immunotherapy CT scan, and among them, sorry, I think I ordered quite wrongly. So number of new lesions are like this. So this is based on total number of patients, and this is based on total number of regimens or treatments. And this is actually the extra number.
Mhm.
And I classify them into like new number of lesions category not having any new lesions, or like having one or two or more than 3 lesions.
Mm,
And yeah, these are percentage distribution.
okay.
And like, and I did pretty much analysis that was done by Wang. So I try to look at is there any difference between patients who have progression without new lesions or with new lesions, and there was no difference, between overall survivor between two groups.
Mm,
And when I include the patients who did not have progression as a reference group, they both were different from them. But yeah, again, there's no difference between those two groups. But interestingly, when we classify them, them into subgroup, like single new lesion, 2 new lesion, more than 3 new lesion,
mm,
the plum color, more than 3 lesion group did poorly. And it was marginally significant among these 4 groups. But when I put the
wow.
reference, yeah, yeah, when I put the reference group as having, people having no progression, then weirdly, like it's a kind of tricky to interpret, but patients who let's say who, so I think 12 means patients who progress without new lesion, and then the patients who progress with more than 3 new lesions, they both were showing poor survivor compared to the reference group, which is patient without progression. So I got this idea from this chart. I got an idea that I might have to separate patients who have new lesions into who have less than 3 new lesions and more than 3 lesions.
Uh-huh.
3 lesions. So I kind of reflect this to the further analysis.
Uh-huh.
And this is this is overall survivor, and this is progression-free survival. And for progression-free survival, yeah, pretty similar trend was detected. And weirdly, like patients who develop single new lesion or 2 new lesions, they were not that different from the reference group. Here only like single new lesion. I think it definitely shows us that the number of new lesions is important or correlated to the clinical outcomes. And this is another story, but I think I try to do what you requested for us. So this is just for Champia group. So there is, if you look at the, I'm sorry for flipping, you go back and forth, going back and forth but for the Champia group, when we look at the single regimen, I mean, total number of patients, there were 4 patients who detected to have Champia progression. And then when we include new lesion, it increased up to 11 patients. So I try to compare these two groups in terms of their tumor size change. And if you look at here, these 4 patients represent the patients who have original definition of Champia hyperprogression. And then here, I actually was not able to match the color, but if you look at the trend, and y-axis are different, so we have to be cautious about that. And so I was asking, like, I'm wondering, do you think we really need this kind of plot or figure in our paper? I kind of find the one pitfall of this kind of approach, which is, I know you might want to see the slope change, but then these slopes are not exact, not accurate in terms of comparing, like deciding hyperprogression, because it doesn't have it. When you look at closely the definition of hyperprogression, it does have like time intervals, but then we kind of apply the same time interval for every single patient with, so technically saying we have to modify time interval for each and every patient if we really want to calculate the slope that is used for hyperprogression definition. So but then these are very relative time interval that I apply to all patients. Like we just yeah. So
So the left is the regular RECIST-based hyperprogression. Right side is the new definition we applied.
yeah, when we include the new lesion into calculation of sum of lesions.
So number 1, I think you have to put time as real time. So number of days, weeks, month, whatever timeline you want to use, you have to. You can have the same starting point, but some will be short x-axis, some would be longer, depending on when you got the scan. So
Yeah, correct.
so you have to put like a real time there. And I think this is deserves a spot in supplemental figure because people will want to see what's going on at with individual patients.
And it would probably be nice to match the color, right? You
Yeah.
want to.
It would be nice to match the color if you can do that.
I'll try, but
And it will be probably good to also match the y-axis scale.
yeah, sure, that can be done pretty
Yeah.
easily. And then are you okay with me using just number 1, 2, 3, 4 instead of NRM, right?
Right. That's preferred.
Okay. Yeah. Yep. Okay. And then okay. You want me to draw this kind of figure for each different Champia and Sarabujit as well, or only for
Yes.
Champia?
Yes, for all methods.
But then, if you look at the Ferrara, okay, so Ferrara, it will be like the left one will be for Ferrara, the left
Nothing.
graph, yeah, nothing, and then only 12 patients will be on the right. That would be fine.
Yeah,
Okay, got it. Yeah. And I'll do that. I'll draw this graph based on only the data set consisting of patients, not regimen.
yeah,
Is that okay? Okay.
okay.
Okay. And then what I did next was actually like you remember, you probably remember what I did, the format of survival analysis that we did previously, but I try to do that differently this time. So I kind of differentiated groups into 4. So non-PD, like patient who doesn't have any progression on their first scan, and patient who had hyperprogression defined originally, original way, and patient who have hyperprogression when we apply the modified definition, and patient who had non-HPD progression. Does this make
By what, HPDC?
Yes, this is for, yeah, I did this for each different hyperprogression definition. So this is for Champia.
Yeah, so the last one, you have to say non-HPD, CPD.
Oh, yeah, that makes sense. Yeah, I will update the legend.
Yeah, this is fine. This just shows, yeah, how they.
Yes,
And you have to do this for OS?
yes, I did that. But weirdly, like, I think this is really interesting. So if you look at the modification really doesn't work, right?
Yeah,
Well, but then when you like exclusively include patients who do have more than 3 lesions of 3 new lesions, the dark green graph really changed it drastically, right? So for this, I only included patients who have more than 3 new lesions for the modification group. Does that make sense?
okay. So
Yes.
then,
So if you, yeah,
then it's,
yeah,
okay.
yeah, obviously, like it's not statistically significant, but it shows some difference,
Mhm.
showing some difference. And then for over survivor, it kind of works better. So unlike, I even noticed some difference between PFS and OS in terms of the effect of the modification. So this is OS, and when modification looks slightly similar to the original definition,
Yeah,
but if you only include patients who develop more than new 3 lesions, it actually did very similarly. So I think this would signify, I mean, we can interpret that if we want to include new lesions into definition of hyperprogression, if we exclude like 1 or 2 new lesions, then that might be working.
I don't understand your last point. What do you suggest?
Okay, yeah, I'll rephrase that. So let's say we are very interested in incorporating new lesions into the definition of hyperprogression. Then I think this data shows us that it's important to consider the number of new lesions.
I mean, that's what Wang has been saying.
But then if you look at closely to Wang's paper, they actually didn't do this analysis. They for new lesions, they only like compare among the patients who develop new lesions and their overall survivor, but then they didn't incorporate this information into the definition of hyperprogression. So when you look at these figure like they didn't actually classify the number of new lesions.
So they have with and without M and L.
MNL means
Multiple new lesion. Multiple new lesion,
Yeah.
Eugene.
multiple new lesions.
Yeah, they make a new term. So if you read in the first paragraph,
Uh-huh.
they make a new lesion. They make a new term that multiple new lesion. They make it MNL. So it's like their term.
Oh, and what was the criteria for multiple?
It's not like a criteria. It's just like he like said like
Oh,
yeah. It's like if you
Hmm.
like more than one new lesion, it will be like show the increase of the hyperprogression, like one lesion compared two lesion and compared three lesions. That's what this paper like kind of show.
yeah, thank you for letting me know. I kind of missed that information. And here I think it's kind of confusing because more than one new lesions and parenthesis and more than two detected on first evaluation were defined as multiple new lesions.
So it's more than one, so not including one. That's why it's greater or equal to 2.
Oh, okay. Then for us,
For us, it's
Yeah,
3 or above. Mhm.
yes, I think that's what happened.
So it is not part of the definition. It's just how they showed, within IHPD, number of new lesion has different prognostic impact. For their paper, the cutoff was 2. Our paper, the cutoff is 3.
Yes.
So I think they were doing similar things here.
Mm,
But
Yeah,
it's
makes
not part of the definition. I'm not going to define true hyperprogression as someone who has multiple new lesions.
yeah, that makes sense. Maybe we can just describe
Yeah, just
um
describe what you found and the difference between Wang's paper and our paper, how it's different.
okay. Yeah, but still like Wang they mm, they only looked at each component of never mind. Yeah, I think I got mistake. So okay. And yeah, Sadab was a pretty similar result.
Mm-hmm.
This is overall survivor and yeah, similar. So
Mm. Same thing here. When you say non-HPD, write HPDS.
yeah. Okay, so and then for this is another story, but Dr. Che, I saw the article that you introduced for us. Article that shows the association between genetic alteration and then hyperexpression. Then actually this is the genomic alteration data of our data. And if you look at here, only a handful of patients, except EGFR, only a handful of patients have the alteration data. Most of them, more than about a half of them, or more than half of them, they don't have genomic alteration data. So I think so that maybe this may be the reason why I was not able to find any correlation between genomic alteration and hyperprogression in any definition. But do you have any idea like how we could move forward?
So I guess no alteration.
We only collected, those
Yeah.
information as of now.
So if you for these 3 within HPD subgroup, you can see if any of these It's
Mm.
still a small number, but whether this has any OS implication.
I mean, to actually discuss that, I think the best we can do would be just descriptive, like some specific types of alterations were detected among hyperprogression patients, but I don't think we can produce some kind of significant statistical results.
Yeah, sample size is small, but still, let's say, look at the EGFR. You have, 122 patients. So make Kaplan-Meier curve group 0 versus 1.
Only for EGFR, right? I think.
No, you can still do it for the other two.
Yeah, I'll give it a shot,
And,
but
yeah, I don't think you'll find much, but still, if you could at least put that in the supplemental figure. So I forward you the new paper from the genomic alterations in HPD. Did you look at it, or Dr. Jian, did you look at the paper?
I briefly looked at it,
Can you
and then
show,
they have,
yeah, can
okay,
you show me what they found?
this is,
Yeah,
so, I actually didn't look at thoroughly, but then even for table 1, they have very kind of
Uh-huh.
multiple variables, and I know their sample size are pretty small as well, but they, how can I, and maybe the findings be,
Can you show me the title and the authors?
sorry, can you,
Title and authors.
okay. I'll
So,
just reopen it, yeah.
yeah, so Dr.
Oh,
Dr. Kato is my friend. Dr.
oh,
Perdrag is my mentor.
yeah, I noticed that.
It's the UCSD data set, and they looked at everyone who got the immunotherapy, and they have their own definition. So they compared, so 155 patients,
Mm.
MDM2, MDM4 amplification.
Was
Uh,
seen,
Yeah. Poor patient, new large masses, significantly accelerate progression rate.
Hmm.
Compared with the 2 months before immunotherapy. MDM2 for EGFR. 2 of 10 patients were also hyperprogressors. Yeah, so I agree. Both are the known, but yeah, show me the graph.
there is no, I don't think,
Yeah, here, pre-immunotherapy, post-immunotherapy, baseline imaging. So yeah, you can do it like this. Remember the graph you showed me? You can label it like this.
okay, I'll refer to the label, but the time point will be not like this. It seems
Right.
like they, yeah,
They just simplified it. You know what? Looking at this might look, I'm not. No, I like the real time point.
But Dr. Che, I think if we put a real time point, it will be kind of disorganized. I don't know. I mean, if we put it like really in the Excel, we put the data and we make it like in the real time point. Maybe it won't be looked so neat like this. because there will be like something like shorter and something like under longer.
Hmm. You're right. Maybe it might be, I haven't seen the real, the graph that I want you to make yet, but it might be more difficult to look at or interpret, so. Let's,
I
do-
think
let's,
we can make both and you can compare.
Yeah, let's do that. Let's make both, and in either case, we can use it. We might end up using it all for supplemental figures. But yeah, let's do one just like this. Let's make one for real time.
Okay, that's okay.
And also remember what they did. They did time to treatment failure less than 2 months. So I think that's, I mean, I know Dr. Kurdrak likes that endpoint. So we have decent number of patients for us to do exactly what they did. So, but they did, a lot of patients had NGS. So, the authors here will be the reviewers, if we submit our paper. So they're going to ask, what are the genes that you found? So I know you collected, but at least you should go back to the NGS. And just because of this data, they will ask, did you also see what they found? So we need also endpoint of TTF1 less than 2 months as one endpoint. And then we need NGS describing whether we found MDM2, MDM4 amplification. Along with, if you look at the other mutations, along with other mutations. So I think we have to be more, because we have the data. We have a lot of NGS, whether it's in-house, Foundation, or Tempus. We have the data. We just haven't collected it in an Excel spreadsheet, other than the 3 mutations you said, right?
Right. Right,
Yeah.
but yeah, that means like basically we had maybe the people who are in the lab may have to open the patient chart
Yeah, I think we have to do it
again.
because we have this paper now.
Dr. J, do you want to make a table as a main table or supplementary table?
It depends on what we find.
All right.
Yeah, most likely supplemental, but if we find the same thing or something interesting, I think we have to show it. Yeah. So basically, show me the DNA mutation table from that paper.
Okay.
So basically, do what they did in the paper, okay? So they have gene alteration list here.
Sorry. Yeah.
Yeah. And then p-value, and then they have this TTF1 less than 2, more than 2, and that's their way of. So let's understand what they exactly did. And these are everyone who had hyperprogression. 49,106. That's so let's go up to the abstract. Let's understand what they did. Let's go to method.
Method.
Okay. So they described case. And then NGS was foundation 1. Clinical information. Prognostic score. And then yeah. NGS. Okay, go down. Statistical analysis. Okay, go down.
I think the definition of hyperprogression is in the abstract.
In the abstract.
I think so.
Can you go to the abstract?
Yes, here, like, we defined hyperprogression as TTF less than 2 months and 50% increase in tumor burden compared with immunotherapy imaging and more than 2-fold increase in progression piece. So I think Dr. J, the reason why we didn't include like Kato's definition from the first place was that we found it's a little bit hard to define hyperprogression using these criteria.
So
I think,
they use
yeah.
their previous definition, right?
Yes. So we have this TTF. We can calculate TTF maybe, and definitely like we can calculate tumor burden increasement. But I think it was kind of tricky to define progression pace. It's defined in the original Kato's paper about
Oh, it's a
H-
WHO. What they use the WHO,
okay.
right? Response criteria. Did they? I can't.
I'm sorry, I actually cannot remember it. But in the like drama paper summarizing all the different definitions, 5 definitions, like I remember we didn't have enough information to calculate this variable at that moment, but
Oh, okay. Yeah, I think it's gonna take too much time to get their definition, because I was thinking if you look at the graph, I thought they were just doing the TTF1 less than 2 and over 2,
right.
but then
That was, yeah,
but that's part of their definition. So they're
right.
they're not going by their HPD.
I might have to look at close, but here it's table 1 is just about the table characteristics, and some articles do like this. But then for hyper, maybe not sure how they actually. Oh, sorry. Yeah, maybe I have to look at.
So I'll give you instructions. Number 1,
Okay.
TTF 2 as a cutoff. I think you can do the same analysis as they've done with the mutation profile. That's easy. So you can do that. Number 2, if you, you could, because I think our main definition we used was hyperprogression by Champiad.
Correct.
So Champiad hyperprogression, yes or no, you can use that to see difference in these mutations in our paper. So you, and that would be our main method, but we also wanted to compare our finding with the Kurdrock's finding. So we will also use 2-month TTF as a cutoff. I'm not going to use their definition for our paper. I'm not going to calculate the progression pace. I will just settle for the 2-month and that's it. Read Kurdrock's paper to see if they use the hyperprogression definition in any of their paper, because the data they're showing is just a TTF, and that is part of their hyperprogression definition.
Yeah.
So I'm not so sure what they exactly did.
Yeah, me too. Okay, I will try to figure it out.
Yeah.
Yeah. Okay. So for the, just to clarify it, for mutation profile analysis, only 2 criteria we're using, right? First one would be TTF less than 2, and the other one is Champia or not.
Yeah, I want to be simple. Yeah.
Okay, and so Dr. J, my last question is actually like before referring to Wang's paper, we actually didn't think about the new lesions, and we didn't have any of these data, right? At that time point previously, but we
Right.
do have these Kaplan-Meier curve, and so I just want to know whether these new information would affect the rest of the table or figure format or content. For example, like table 1 would be same, 2 be same, but then and I'm not gonna do landmark analysis for this, and for the format, like, do you still want me to keep this format? I'm kind of confusing. I'm confused about whether I should incorporate kind of information on the new lesions into like every single PFS and OS table, or do I need to consider that also into multivariate or univariate analysis as well? And for the risk factor analysis. So it feels like, to me personally, it feels like it is too huge to be contained in just one paper, maybe because Wang, they didn't even look at risk factor or multivariate analysis. They only compared Kaplan-Meier curve with or without, or with subgroups in terms of new lesions. That's what they did for one paper.
So
And
for modified, we
Yeah.
know that it did not outperform. both
okay, yeah,
PFS and
did
OS.
not.
It did not. So for modified, everything, you're not deleting anything. For modified, take everything to supplemental. Okay,
Okay, but yeah,
we're just going to show different definitions and how they are different in prognostication.
but then couldn't we like argue that when we modify it, and then when we consider the number of new lesions, that would be working similarly to the original definition? Couldn't we argue that based on our finding?
We could show these graphs that are statistically significant, like you're showing right here.
Mhm.
However, to make that argument, I mean, we can show it, but it's weak because the sample size is too small. It's like a 3
Mm.
patients.
Right,
And
right.
they happen to be the worst, performers. So because we're dealing with very small number by subgroup analysis,
Correct.
yeah, that should not be our main point here.
Okay.
But you can
Makes
say in the discussion, yeah, Wang's paper said 2 or more lesions. In our paper, it seems that 3 or more lesions were the subgroup that did the worst. And as did that as was the worst performer, as much as the original hyperprogressors did. Something like that.
Okay, so for modification, all the results will be in the supplementary figure or table.
Right,
And
but all the tables, but the figures that showed meaningful separation, you can select them. I want you to show them all in supplemental figures, but the ones that showed significant difference, including the 3 or more, and I think we can put all the progression-free survivals in the supplemental because they didn't show much but OS, including 3+, that graph can come as a regular figure.
okay. OS for OS. Okay.
Because Wang's paper used OS too.
Yes, that's true. Okay. And for regular PFS and OS, are we we're gonna only keep like original Champia, original Sarabusit, and modified Champia, correct? Still?
No, we're not keeping modified Champion.
Or okay, well not.
So everything modified goes to supplemental.
Yeah, it was previously in this column, but I will.
And the reason
makes sense.
it didn't do any better job.
Yeah, I think it's hard to actually see the superiority of the modification. Yeah, but yeah, it was not superior. So I will just delete it from this prognostic table as well, right? Correct?
Correct. So
Okay.
so this is a strategic decision because in the paper, let's say if it showed better prognostication, better predictive value, and these are the group that did worse, then it makes sense to stay. But
Right.
we're not
Okay.
claiming that this group refers to be the new definition that I think we're suggesting and then just neutrally say, if we do that, this is what we saw in our data, and just in the parentheses write like supplemental table and figure what, so and so. That's it. That's how we're going to present. And then we can argue, what was the impact of having new lesions, and this is what we saw. We believe a lot of HPDs will have new lesions, but the fact that the current HPD definition does not quantifiably measure new lesions and in a quantitative way. So we are proposing this method, but also this was validated by Wang's group. But I guess you have to say what we did was different from what Wang did. What was different. So that's kind of the tone of the paper.
Okay. And for risk factors, I was wondering whether I could include the number of new lesions as a factor because it was shown to be correlated with overall survival in our data. But for example, like another like variables in this table as another variable in this table, like maybe new lesions more than 3. No, yes. Of course if it's not necessary, then I won't do that, but just wondering.
So baseline and pre-baseline. To
These are
explain,
the, yeah.
what it,
For Champia, unlike Sarabusid, I think I mentioned it previously, and I still figuring out the science or mechanism about this results, but weirdly, like only Champia definition, it was correlated with the baseline and pre-baseline tumor burden. So basically, like patients who had hyperprogression had definitely larger tumor burden, both at pre-baseline and baseline.
Yeah, I think you just have to discuss that. The larger tumor are prone to undergo hyperprogression.
Yeah, you kind of gave us a hint, like larger tumor, higher chance for heterogeneity, and yeah, I'll look up some more articles on that. Okay, I'll just leave this table like this, and not adding any new things. And okay, yeah, I think I figured out all of the questions that I have. Yeah, I'm not gonna use this landmark table. And all right, I will make all the supplementary tables based on the new findings about new lesions information. And
So when you write discussion, there's going to be a lot of paper looking at the association between the tumor size and the response to immunotherapy. What have others seen in general? Do large tumors respond better to immunotherapy or smaller tumors? The next question is, did they actually use RECIST criteria to do that measurement? And did any hyperprogressor risk factor analysis prior publication seen something similar to what we've found? And what were their numbers? So that's all part of the discussion we have to describe.
okay, yeah.
And if you remember that hyperprogression review paper, I can't recall whether tumor size was risk factor or not, but I don't remember. Do you remember? Arnie, do you remember? So Eugene, you remember the paper, the review paper, right?
The review paper.
The hyperprogression.
Oh yeah, the one that containing 5 different definitions. The
Yeah.
JAMA. Yeah. Oh, do they have
I think there's a risk
results
factor.
about risk factor?
There's something about risk factor. They have a table or something. Look into
I was
that.
only
Yeah.
I was only okay. Yeah. I'll look into that later.
And I'm thinking based on what we described with what we discussed with Stas, that might be different squamous versus adeno. Like, that relationship really, whether the immunotherapy works well in high ITH or low ITH, because we believe usually ITH correlates with tumor size usually, but if you have a driver mutation in adeno, that reverses. So what I'm saying is this crude relationship may change, but based on the histology too.
Mm,
Mm.
But again, if we, I mean, we're not dealing with like 200 patients here, so still we're limited in sample size to look into that kind of interaction. But
Actually, most of the paper that I researched the risk factor when I write in the discussion, Dr. J, most of them like it's not like the like LDH level or like the number of metastasis is the one that kind of show as the risk factor when I write the discussion, and I try to find each previous article about it. PDL1 is only discussed, I think, by one article that have as
so
a
my
risk factor.
question is the tumor size. Okay, you both can look into it while we proceed with other presentations. But here adenocarcinoma at higher rate, but also, you know, small sample size, it's 3 versus 0, so it's hard to say, but adeno had more progression. And I wonder, because MDM2 amplification and EGFR mutations are more common in adeno. So I wonder if people are interested in knowing, did all 4 of these adeno hyperprogressors have EGFR or something else? So these are good questions that you really need to address in your results section. Okay. Like, we're not talking about many patients here. If you look at it, we're only talking about 3 or 4. So, you know, what are the genetic features of all these hyperprogressors in table? Okay, each one. They could all be in supplemental table. Because they all ask who they are. What these mutations are.
So bit descriptive on the genomic alteration information on the patients who was detected to have hyperproportion, right?
Mhm.
Okay. Yeah, I
Not
think
just mutations, but copy loss and amplifications as well.
okay. All right. Yeah,
There's a lot. Each time we discuss, there's a lot.
I know. I thought this project would be finished it by the end by
Yeah.
2022. Yeah.
Dr. Che, do you mind to read the introduction and discussion part a little bit? I will send you the link if you don't mind to review it a bit.
Yeah, let's do it. Let's take like 10-minute bathroom break and then we'll start with that.
Thank you, Dr. Che.
Arnie, ready?
Yeah, I send you the link, Dr. Che. I send you the link for the manuscript.
Can you send it? Oh, in the chat.
Yeah.
Okay.
Just the introduction and the discussion part.
Okay, do you see it? Oh no, this is the other one. Where's the other? Okay, do you see it?
Yeah, I see it.
You don't have to write this here in the abstract. You can write that in the methods.
Okay, Dr. J.
So be consistent. I think we decide to use what Eugene showed in her graph. So
Yeah.
use that.
I will revise that for the abstract.
And use consistent tense. You use past tense here. Here you need to use past tense, okay?
Yes, Dr. J.
Some people use present tense and you have to be just consistent. What is reflecting the total tumor lesion? What do you mean by reflecting?
Actually, to be honest, Dr. J, the abstract hasn't been edited yet because last time we keep a lot of change. So I just make the introduction and the discussion first. After like you quite okay with the analyzing and the discussion part, I will revise the abstract.
Okay. So reflecting is not the ideal word, and you should change. You should introduce the idea. Well, I guess I don't understand what you mean here. Do you mean the total accounting for adding new lesions?
I think this is like the size, like the tumor size, reflecting the total tumor like size, I think, like, or the tumor burden. Like the new target lesion. I think we need to I will try to change the name, the total of like the new target lesions. I think it will be better.
Okay, so before you write introduction, I always tell my students to write abstract. Abstract has to be perfect. Because if this paper goes to reviewer, they'll read abstract and abstract doesn't make sense, they will stop. They will not review the paper. Okay? Abstract has to be spotless. It has to have all the key logic. Don't try to write abstract at the last minute, you know, after you write everything else. Reflect. So again, this is tricky. So I'm telling Eugene and Arnie and Xian, it's tricky and it's a strategic decision. The new definition is tricky because it did not outperform the current definition. So we're going to say, in the method, we used our own way of assessing hyperprogression by adding new lesion into the tumor measurement. And that is not RECIST way. That is a different way. We're just proposing for the hyperprogression. So you have to say that's our new method in the abstract method section. And then say, if we apply that method, this is the new incident rate that we see. We're going to stop there. We're going to not discuss the impact of its prognostication power later, because it did not outperform. We're going to say that this can be a new way, and in the not in the abstract, but in the paper, we're going to discuss what it actually showed. So we're going to be very neutral. And in the abstract, it's okay to mention that in our paper, 3 or more new lesion had clinical impact. So you have to be very strategic about what to put in abstract or not. This is the showcase. You go to a store, you look at the show window and you decide whether to go into that window shop or not. So abstract has to be perfect, logic, choice of word, everything. Okay. I want to emphasize that for every paper you guys write. If abstract is not good, I myself, reviewer, I don't read it. Honestly, I don't read the paper. If the quality is too poor, I stop there. I don't want to waste my time. I just look at some of the figures and I stop. Okay, introduction. What are all these numbers?
It's the number of the reference. I put it in the table. I put it in the box first before we put it in the citations later.
Whether it's RefWorks, EndNote, I don't care. I want you to put that as a reference when you write it. Don't try to do that at the end. The beauty of using the reference program is that, let's say, if you move the first paragraph to come to the third paragraph, the number will change accordingly. Everything is automatic. So as you put in reference, make a habit of putting them always with the text, okay?
Okay, I will fix it.
Makes me very dizzy to look at the numbers stand out. So again, it's hard to estimate the size of the paragraph because you have so many numbers here. This one, if you look at it, 1, 2 sentence. 2 sentences is not good enough to make a 1 paragraph in many cases. So again, I want you to rewrite the whole thing. It has to be, what is hyperprogression? The definition. And why is it important? Only in the setting of immunotherapy, not targeted therapy, not chemotherapy. Why has this concept been important? Because it has only been described in the field of immuno-oncology. And then describe the different definition and what others have found in terms of risk factors. And then, what is this? I wouldn't say it's easily confused. So if you think about the hyperprogression definition, they don't have a confirmation scan. So they don't have number 2 on treatment. So HPD by definition will contain pseudoprogression. Does that make sense to you?
Yes.
So it's not confused. Some HPD will later be confirmed as a pseudoprogression. It's not confusing. Definition is different. And that is one of the biggest limitation of the current HPD definition, that it does not require on treatment number 2 CT scan. So that has to be discussed in the discussion. And the fact that we have actually looked at number 2 scans for all our hyperprogressors, and that confirmed that we did not have any pseudoprogressors. Okay, so that's a very important point.
Yes, Dr. J.
So you don't have to define pseudoprogression here. I think this is a fine point that you can discuss what pseudoprogression is and how that is a limitation, and what we did all goes to discussion. However, you can say some hyperprogressor will later be determined to be pseudoprogression, not true progression. I think that one sentence would be good enough.
Okay, I will revise it.
So here it says, although risk factors were reported, such as other risk factors that were reported.
I mean, so basically the way I want to say is like this, Dr. Che. So there is like each paper show their own risk factor, but there's not a lot that each paper have the same risk factor. So each paper like can kind of say like different. There's only 2, I think, that have like kind of like maybe 2 paper like mention the same risk factor, but most of them like say like really various risk factor. No one like have a really one significant risk factor that kind of the same for each paper.
So again, if you want to discuss how each paper are different, that's for discussion. You don't want to discuss each paper, and you don't say in a systemic review in 2020. This is going to be a reference. So multiple risk factors have been proposed in various studies, but there has not been a risk factor that was I wouldn't say reproducible or replicated or validated and so just describe it in more in a, it's limited, and it was only described in a few studies, and none of the risk factors were validated in a larger study. Just be more general, okay? You can still cite those papers and describe what they are and what were their impact, and some of the risk factors that we found were previously reported, was never been reported before. So you're going to go through the details in the discussion, but not in introduction. Okay, so you could say such as so, but maybe you pick 1 or 2 that has been described in multiple papers, a little bit more validated than the other. You can be general about the trend, but you don't have to go into each paper and describe what they are. Do
Okay.
you understand that?
Yeah, I understand.
Okay. So I don't understand why you said this. By reflecting the clinical response of all new lesions.
Actually, this is the purpose of what we discussed before in a couple weeks lab meeting before. I think we want to show like before, like we haven't put all the new target lesions to our analysis, Dr. Che. But right now, if we redefine HPD by reflecting the clinical response of like the new target, that we include the new target lesions to our sample.
Okay, again, this is in line with what I just said. We have to be very strategic about what we want to do. We're not saying that our new definition is superior, or it has to be the new guideline. So I think it's dangerous to say this. So it's all about nuance. How do you describe what you want to do? So again, this is writing introduction 101. First, the concept. What is HPD? What are different definitions? And what is the limitation of current definitions? Then because of that, we want to describe the new method of describing HPD. And what are the current knowledge of risk factors? And how and what is the limitation? Are they accurate? What do we need to know? Same thing with the incidence. What is the current knowledge of incident? And is that accurate? And is there, what's really going on in clinic? So we have to talk about number 1, incident. Number 2 is risk factors. And number 3, clinical implication. So what is the current knowledge and what are we lacking? What is the limitation? What are we trying to do? So we're going to look at, so again, what's our hypothesis? What are we actually going to do? We're going to look at this number of data in real clinic in our database and see how explore these factors. And then for the our new definition, we decide to add new lesions into the tumor measurement, tumor size assessment. And it's not reflecting clinical response. So get rid of this expression. So again, what are we doing? Assessing incidence, risk factors, and clinical implication. That is the clinical implication, meaning how does it impact PFS, OS? How does and then again here, we looked at different definitions. So how does different types of definitions of hyperprogression impact incident, clinical implication, and how does the new proposed definition and the presence of 3 or more new lesions impact incidence and the clinical implications? That's what we did, and through introduction, current knowledge gap, what are we actually doing? We have to write what are we actually doing. And here I think you didn't write what each different type of definition can be different in real world, what looks more practical, and how our new definition can be different. So again, think about it real hard and rewrite the introduction.
Okay, Dr. J.
You want me to look at materials?
The discussion, just go through with it. It's just like 1.5 page, I think, for the discussion. That's all. Yeah, that's it.
So I don't like to use remarkable.
Mm-hmm.
So you have to refrain from using anything. I don't know, sensational, remarkable, you can say it has been major breakthrough.
Okay.
But remarkable is not the right word to use for scientific papers, in my mind. Okay, this to me reads like introduction. To me, this is how you write discussion. First paragraph. What if you have to say one take-home message, what is it? From our study, we learned that number one message, this is what we found. The real world, this is the incident, these are the main risk factors, and you can say every definition you'll get very different incidents and very different clinical outcome, very different predictive power. That could be your message. What is your main message? One or two main message you have to say, this is what we found. So this belongs to introduction, something like this. It tells you nothing about our data. This is a very precious space. Don't waste on writing something generic. You have to write everything about your own numbers, your own study. So the first paragraph goes to, in summary, this is the take-home message. Okay.
Okay.
And then you go to what did the other literature say? Okay. Other literature reported. So I would go, so if you don't know what to write, always go to the title. Title will always tell you what you need to write. So hyperprogression, redefining. Why are we redefining? Because there's so many different definitions. So I would say different definitions have shown different incident, different clinical impact. What are those different impacts? But you have to review all the relevant papers. So in this regard, Minjung's paper is precious because she already made so many different tables on this. So you can cite it. So what did other papers write about incidence, clinical implication, and risk factors? And what did our paper find? I would write that and talk about the similarities and differences. So that's your second paragraph right there.
Yeah.
So you can instance. So here is the check for you to write each key paper. What are their incidences?
Mm-hmm.
And what's our incidence and how is it different? So the next paragraph 2, 3, 4 is going to be, what does the literature say? And how is it similar or different than our paper? Again, I don't like to use one study, Wang et al. This all goes to reference. You don't refer to paper.
Okay, Dr. J, I will.
So you can say the finding. the number of new lesions were reported to be correlated with something. Just say the finding and you can put the reference. You don't have to say who did it, you know, where it was done, when it was done. It's all in the reference.
Okay, Dr. Che, I will do that.
Okay. So,
Yeah, I will rewrite.
I'll look at it once it's done, okay? I don't think you have it ready.
Yeah, I will rewrite the abstract and introduction again, and later the discussion. Because the discussion actually, like I also waiting a little bit for our analysis, so can reprise can kind of put in the discussion also. Thank you, Dr. Che.
You're welcome. So yeah, so I think to read a lot of NEJM science, those papers, how they structure their introduction, discussion, that is the best way to learn. You know, what are the words that you used? Yeah, writing is super important and it has to have a logic. You can't have a leap in your logic. Make sure there is a thread of logic and yeah. Okay, I'll stop here. Okay. Let's see. I guess Jion, you can go next.
Yes. Mm. Okay, I will start with the double lung transplantation. So as we try to change as the original article, so I will split as a 3 different article with original about the survival outcomes of bilateral lung cancer and the incidence of a post-transplant lung cancer only in double lung transplantation. And the second one could be the brief communication, which is about the post-transplant malignancy, including other types and the lung cancer after double lung transplantation. And third one could be the review article. So this is the first one. And so it's been changed as original article. And then international registry team reviewed this article and they changed it several points, but most of them I can handle it. But they said that because the international registry contains the US data as well. So of course, looking at these numbers, most of them seems to be US data, but do you still want to analyze them separately?
I don't think we need to. I mean, whether it's US or not doesn't really matter. I guess because we have UNOS and ISHLT, we just have to explain that we cannot separate, or like it's well, I guess in the method we did say we will explain that will be overlapping, but you know, and the data is all structured in a way that we are not able to separate the overlapping data. Yeah, I think we just explain it in the method. That's yeah.
Because I want to still keep them, leave them this way, because we can still show them the US trend versus international trend. So.
Yeah, but the international contains US data, right? Yeah, that's okay.
And how about this, the figure 1? This is about the flow chart, because we contain so much, a lot of data, which is extracted from the case series and UNOS data and international registry. So this might be more clarified for the readers when they read our article. So could it be?
I like it. Do you think it should be regular figure or supplemental?
It could be supplementary.
Yeah, let's do it supplemental.
Okay, thank you. And now I'm watching the double lung transplantation for non-cancerous disease data right now. And I analyze a part of that. You can see from the UNOS data. It was 29,000, more than 29,000. And this is 220 with a post-transplant lung cancer only, without any other malignancy. And the 29,100 patients did not have the post-transplant lung cancer, and they also didn't have any malignancy after transplant. So now I'm trying to make a survivor curve. And it looks similar actually in 3 years and 5 year survivor. So this could be the first original article.
What is similar? Can you explain?
Oh, well, you can see the percentage 3 year, 5 year. I didn't do the statistic analysis, not yet, but I will figure out. But when you look at just the number here, 3 years over survivor of patient who received double lung transplantation and who had been diagnosed as post-transplant lung cancer shows 63% 3 year overall survivor. But without lung cancer, it is inferior than the patient who had post-transplant lung cancer as 52%.
I see.
But that is conversed in the international data. But well, so that's why I still want to show UNOS data and international data both.
Sure.
Yeah. So today I will do the statistical analysis and we'll make a graph. So I will finish this one within January. And second one could be the review article. This is now it's been holding because I'm working on the original article, but I will go through. And third one, as we have the post-transplant malignancy data, but it is only available from the international, not UNOS data. But still, we can use it because international data contains most of US data. And as I'm thinking, how about this concept of article? Well, I want to contain indications of the double lung transplantation for non-cancerous disease. I could distinguish as Ji-san provided the data, and I can make an overall survivor of them. And we can compare the incidence of a post-transplant malignancy versus post-transplant lung cancer.
Yeah. No, I like it. I like it.
Okay.
And then by different cancer types, right? So
yes, I can do it.
that's
Yeah.
Can I make it clear about the data from ISALT and UNOS? So from UNOS data, so the type of malignancy, let me check again. So are divided, so like all kinds of cancer, like ovarian, testicular, esophagus, stomach, small intestine, pancreas, thyroid, like that. And from the ISHLT, they divided the type as lymphoproliferative, like lymphoma or leukemia, and solid tumor,
Oh,
and skin basal cell carcinoma, melanoma, squamous cell cancer. It's all about 3 is about skin cancer. I think that's all. So it's a little bit different between ISL, HLT, and UNOS. So that's all I can say there.
Okay,
But-
then you mean you have, you can distinguish it in your UNOS data as well, right?
Yes, as I said, just so we can divide lymphoproliferative, solid tumor, and skin cancer type.
Okay.
but that's UNOS or
From ISHLT, UNOS divide all types of cancer.
So
Okay.
from ISHLT, do you know if there's lung cancer recurrence?
So from I gave Dr. Jian about the data. So I sorted it out by selecting the long word from the data. So it's I think I
yeah.
think so I think I can provide all kinds of cancer from ISHLT because they organize these by using text. So maybe I can sort out from the data by using the keyword like long or what else?
Okay, when I
Kidney
saw
or anything.
the data that you gave me about the UNOS, there was a 2 recurrence in the patient who received the double lung transplantation for lung cancer. That means the 13 patients didn't experience recurrence. But that doesn't make sense because the most of article shows higher recurrence rate, but only 2 among 15 patients. So I thought that it's not reliable. So can you check it again?
You mean from UNOS data?
Both, if
Both.
possible. Yes. I want to include
Sure,
in
sure, I
my
can.
article. It is really important in my article. So if it's possible, I really want to contain that.
Okay, I'll let you two sort out. I think we'll need to go by each organ site.
Mhm.
Yeah, but yeah, just make sure you're accurate and present every possible tumor types. Yeah,
Okay.
and did we decide what journal for this one too?
Oh, with brief communication, we
Mhm.
didn't decide because it could be 3rd article, which is popped up very new.
Right, yeah.
So-
Maybe we can ask Dr. Barat once we have like an idea and the figures, we can
Mhm.
ask him, do you have suggestion for? It has to be surgery, transplant journal or
Okay.
yeah, or surgery journal. Yeah, thoracic surgery. Post. These are all lung transplant, right?
All
So,
double lung transplantation.
yeah, all double lung transplant and post-transplant malignancy. I really like JTO. I think Journal of Thoracic Oncology. Well, this is not. Well, this is still cancer coming up. But
Yes.
still, yeah,
Also transplant cancer.
it's thoracic oncology in a way that post-transplant there's cancer coming up. So, and some are lung cancer, some are not lung cancer. You know, it's still thoracic and oncology.
All cancer.
I think, yeah, you can look for thoracic surgery journal or JTO, either one. That's
And Predicen gave me an email, and I think they're doing the blood sample and just test. And they asked me how to proceed the tissue and just test. I'm still trying to figure out any reference which they someone used the frozen tissue to evaluate the TIL. But up to now, I couldn't find, but I will look it again.
Who would know this better? I don't know. Because I think the Lunit's response was, it's not accurate, right?
No, I don't think so.
Yeah. I guess we just have to find a pathologist who are well versed in this field. Frozen tissue. Okay, yeah, keep looking.
Okay. And unfortunately, second court maybe should be holding right now. And I will discuss later with you. And sorry, I couldn't prepare the journal club today, but I found the reference when you asked me. So this could be the journal, the exact one, with the zoledronic acid versus denosumab about the adverse event. So I will prepare in next meeting.
Okay, sounds
That's all I have today. Thank you.
okay. Thank you. Liam, you have Jisang? Maybe Jisang, you have update? I know you just came back to lab, so quickly, do you have anything to add?
Actually, I don't have any update for now. So,
So tell me the plan for radiomics.
Right. So I received from Dr. Jian about the data. The clinical data to fill in, and on I remember about 20 patients that clinical data were gathered, and about 80 patients left. So I think I need to fill it in, and
So Liam, remember the clinical trial startup team that came to my lab from Asan Medical Center?
Yep.
Are we able to use it? Or where are we in terms of?
We're still organizing the data. So they requested the data to be organized in a very specific way so that they can feed it into their SIS program. So we're still working on that. And I was hoping that now that Dr. Chisang's here, we can finish doing that and then send that over.
So the resist and all the measurement, once we do that, Dr. Chisang can use the program to do the resist, or is that? the plan?
We should be, but then it's going to take some time to set up the program with our data set and with like our clinical variables.
Oh,
But once we set everything up, I think it's just the initial setup that's going to take some time. But once we set it up, like afterwards, it should be much more easier.
so work with Jisang, because I want you to know the program and
Yeah.
work with the company directly. So, I mean, do what you have to do, Jisang. Don't wait till they convert, but also work with Liam and the company to send them all they want so that once they have the program running for us, then you should work through the program. It's much more efficient. Okay, so let's have that as a goal. Okay, anything else? Okay, let's
No.
for now. Okay. Yeah, Liam, you have a update?
Yeah, I have a couple. First of all, or let's do this first. So first of all, for the MCED, we've Eugen was Juhi was able to gather a list of potential target journals for us. So would like to show that to you.
Okay. So let's look at that paper. Huh. It's not opening from here, so it's
Is it not opening for you? Ooh.
yeah, it's not opening.
Let me try one more thing.
Yeah, it says request access. Do you have access?
I do. Let me just change the settings really quickly and reshare that. Yeah, just resend the link.
Okay.
Does this work, or would you like me to share the screen?
Oh, it's working here. Okay, you see it?
Yep.
So where are we with the journal?
We're still editing it with Dr. Shin's comments, and we are planning to have a follow-up meeting with him sometime soon, TBD.
Okay.
And these are the potential target journals in order of impact factor. You wanted us to compile this list, bring it to you so we can come up with a plan or strategy on when and where to submit.
American Journal of Public Health. PLS Global Public Health. I don't know what that is. So JCO is gonna be really tough, I think.
Mhm.
Yeah. So where did we submit to?
We did
JAMA?
Lancet. We
Lancet?
did Lancet.
So I think we can do JAMA Oncology.
Okay.
And what was the word limit that we had?
So our current version was 3,500.
3,500. Okay.
I believe.
Okay, about 3,000. I guess then we can do Annals of Internal Medicine first. Because it has 4,000 word limit. And then JAMA Public Health, 3,000. 6,000. Huh. So Annals Internal Health Internal Medicine first, and then we can do Plus Medicine as the next, because there's no restriction.
Mhm.
Public Health, American Journal of Public Health. Yeah, I think I don't know if Cancer Investigation. This is a pretty good journal. So I would say I don't know if as a like a journal they would be interested in the topic of our paper.
Mhm.
We could like simultaneously send them like, are you guys interested if we submit? So we can do that for well, it wouldn't hurt to just try. See JCO, JAMA. I guess that you can send it to all the journals. See if they,
Okay.
sometimes you never know, they want like,
Right.
oh, you like the topic. We are actually preparing a special, you know, edition for this, submit it. You never know, you never know. So just do it. But the order, and then I mean we can rediscuss this after that, but with what we have, JAMA,
Mhm.
well, it's 3,000. So Annals, and then go to JNCI, and then go to Plus Medicine. For now, let's have that as 1, 2, 3. But also let's
Okay.
see what other journals are saying if once we write that letter of interest.
Mhm.
Okay, let's do that. Do you guys know JAMA Network Opens impact factor?
JAMA.
They might have a better word limit.
Okay.
It is more than 13.
It's more than 13?
13.353.
Can you see what the word limit is for the network open?
As the original article.
Yeah. Oh, it's all, it's same 3,000, I think.
Yes, 3,000.
Oh, they have like a research letter. This is another good, if we were doing just a brief communication to report something, let's remember JAMA Network research letter. They're 600 words and they're, you know, really, really small, like a brief communication. Okay, so I think yeah, shortening words are going to be painful tasks, so just go with what I just said. So
Okay.
yeah. Okay.
All right. Okay. And then if you'll let me share my screen
Uh-huh.
real quick. So this is for the Guardant dataset request form. We emailed Dr. Firath and they directed us to this Science Data Core, and they've instructed us to submit a request form, and then they can set up a TC with us to discuss the project and get us set up to proceed. So I think I can submit a request for myself, for Stas, and also just one for you as well. It's
Do
pretty.
Do they charge us for this?
I don't know. I don't think so. It's like a data core within the cancer center, so I don't think so. And there wasn't any mention of any fees so far in our communications, which
Yeah,
should indicate there isn't a fee associated with it.
right. And the protocol will be the retrospective lung cancer, that thing, and then.
Mhm.
and then
So
Yeah, go ahead.
yeah, everything else is pretty straightforward. I just wanted to ask a couple of things. Do we want, where is it? Do we want like support from the biostatisticians and bioinformatics, or are we good to go about the project without?
Without.
Okay. And then what about clinical informatics / databases?
What does that mean?
It says like types of clinical informatics support, and then it's got like EDW, data requests, feasibility estimates, REDCap, biobank setup, OncoSet data, REDCap database setup, REDCap project support.
No, we don't need any of those, so it's no, yeah.
Okay. And then the other thing, the title of the project and the brief description of the project, is that just going to be based off of the retrospective IRB?
Yeah,
Okay. Did you want to specify anything, or should I just copy and paste the IRB protocol stuff over?
just copy paste, but yeah. And
Okay.
then you can say this is to get the data from Guardant. So the liquid biopsy, you could just mention liquid biopsy something, and then this is to leverage the existing collaboration we have between like Northwestern and Guardant. So that they kind of understand what we need from them. Yeah.
Okay. Right, I can go ahead and do that. Okay, and then so I'll just submit one for myself, Stas, and one for you. I should be able to do that. Okay. And then the next ones are going to be the abstracts for the AACR, the
Yeah.
clinical trials one. So the double lung transplant, the DREAM study. So like I said, I heard back from Dr. Tomic,
Mhm.
said everything looks good. I didn't hear back from Dr. Barat regarding the abstract itself.
Mhm.
So I'm assuming he doesn't have any comments. Do you think it'll be okay to just go ahead and submit as it is then?
Maybe just send in one more time saying that we're, deadlines the day after tomorrow, we're gonna submit. Well, once you submit, you can still go in and edit, right?
I believe so, yeah.
ACR, you can do that. So just say you're submitting it today. You still have 2 more days to edit. So if you want to give us any revision,
Mhm.
you can do so. Just the FYI, this email. Yeah.
Okay, I'll do that. And then regarding the DART abstracts, so Patricia's like been working really hard to circulate the drafts to the authors and like get their like COIs and things like that.
Yeah.
First of all, let me What am I trying to do? So do we need the COIs of all of the authors when we submit the abstract, do you know, or is it just the corresponding authors?
I think you need for all the others.
Oh, okay.
That's a lot of work.
That is a lot of work. That's why we've been bombarded with a lot of emails.
So the thing is, if you find the author, like you can, if you go and click the author's name, you sometimes they pop up. For ACR at ASCO, a lot of them have already, like the authors there have submitted the abstracts before. So if you find them, their profile should contain their updated COI there.
I see. Okay.
Yeah, that's same for me. Like ASCO, I have updated COI connected to my account. That way you don't have to do it, but if it's like you can't find them and it's not updated, then you have to go in and update.
Sure. Okay. I think that should be okay. What else? And then just a couple more things related to this. Just one more email thread that I wanted to bring to your attention regarding the abstracts for the clear cell cohorts, I believe.
Okay.
So this is a couple of questions that went back and forth between Sharon Elad and Megan, and also Helen Chen. So the endometrial and cervical cohorts, it was a pretty small sample size. So this was this email that Sharon Elad said, and then this was Megan's response. And so, we had talked about, whether or not we should include the iRECIST information, and we had decided not to. And I think there is, I think you can argue both ways. I mean, technically it's not a primary endpoint, so I don't think we necessarily have to, especially at an abstract level. But just wanted to see what your thoughts were. And then this was Helen's comment. And then we also have another one from Elad.
Yeah, so let me go back to the Megan's point. So we're gonna say, I think we just have to be consistent. Like we can't, put percentage for this cohort and not for this cohort, just saying because cohort, so we're just gonna stay. And number two, although we're not reporting immune-related ICR, like as a, but remind me, the iRECIST was done for which cohort?
I think it was either the cervical or the endometrial. It wasn't for the ovarian.
Okay. So we could say that unconfirmed PR had confirmed CR by iRECIST criteria, right? We can say, we can add that one sentence. I don't know if we have room.
Oh, okay, yeah. So if we have room, we'll put it in. If we don't, we'll just leave it out.
Yeah, it was unconfirmed CR, and then in the parentheses, confirmed CR by iRECIST. How or like, so that one patient we can say, that like there's like additional information.
If space allows.
Yeah.
Okay.
But definitely for the actual, we
Of course.
Yeah.
Yeah. Okay. Yeah. So that patient was interesting because that patient was unconfirmed PR, and then in the iRECIST criteria, it was confirmed as ICR.
Yeah. That's good. That's likely to be real.
Yeah. This is just a comment, but I just think the iRECIST is a much better system to work with.
Yeah, I agree. But
Okay.
unfortunately, pharmaceutical companies are not using it.
Yeah. So that's it for now. So we're just getting tons of emails regarding authors, comments, feedback, and COIs and things like that. So I'm just gonna update them as they come along. One question I did want to ask you or run by you is, so for the clinical trials for AACR, apparently they allow us to put in placeholder abstracts for these. And that will buy us like another month of time. Do you think that's something we should explore and exploit? Because I don't know, like
So placeholder means they're not done with their abstract, right?
yeah.
For you, what do you
And then,
mean? I guess,
sorry, could you say that again, please?
so what, practically, what do? You just save and not submit? Is that?
No, so we submit like, to simply put, you submit like a half completed abstract, and then we say, this is a placeholder abstract. We're going to finish it later on when like the results are ready, and things like that.
Okay.
So this is what the guidelines or the call for abstracts say. Yeah, so it's like, if you look here, the final results and conclusions for placeholder abstracts are due by February 7th.
I don't think we need it. I think we can submit.
Okay. So whatever I get by tomorrow, like noon-ish, let's say, I'm just gonna
Submit, yeah.
Yeah, I'll just update data as they come in up to tomorrow noon, and then just start the submissions.
Yeah.
Okay.
And let's, by the end of today, let's finalize our revised version together, for all three abstracts. With what we have, like the input that we get. I'll forward you all those. Once, sometimes you're not CC'd on those, so
Yeah.
yeah.
Okay. Then I think that's it for me.
Okay.
Mhm.
All right, Youngwoo, when are you joining us?
Yes, hi, Dr. Che, everybody. I'll be there in mid-February, February 13th.
February 13th.
Yes.
How long are you here with us?
So I'm going there with my vacation, so like only a month.
Okay, 4 weeks.
Yes.
Okay. Good. Yeah, 4 weeks is pretty good amount of time, I know. Horyun was with us for, I think, 2 weeks, something. Yeah, and he got oral presentation. He got, I think, 3 abstracts, and
Wow.
so you can still do a lot of things, and there's a lot of interesting projects going on. Yeah, you can definitely come and help. This will help you understand what's going on. And I know you did some, so tell me what projects you were involved, excluding case reports.
So
Projects.
I was in like biomarker studies using TCGA, and also circulating tumor DNA with the heterogeneity study, and immune-related adverse events with proteomics. So
Yeah, those are all good. So that definitely the heterogeneity, we have data. I think you could definitely work on that. And Haesung's coming, so she can work with you. You did TCGA, so you know how to do all the TCGA, RNA, DNA, that landscape analysis. No, so you can do that with our own patients. Tempus RNA sequencing data. You can work with Stas on that. What happened to your thyroid TCGA paper?
I'm sorry, but I think it's lost.
It's lost.
Sorry about that.
So it's a landscape paper. I think it's something you could still finish and submit. Right? Isn't it almost done?
We were working on it, and the problem was as we are working on it, there wasn't really significant like results from it. That was because like thyroid cancer is like dormant and it's all surgical sample, so it's not really immune related things going on. So there was some drawbacks true with that.
So to make it more interesting, Lunit has all the thyroid H&E slide imaging. So we can ask Lunit to send us their Lunit score for all thyroid samples. I'm sure there will be maybe 5% of them have high TL. And then you can go back to our DNA, RNA. What is unique about those group of patients? They might have something that's very different.
I'm sorry, where, like, what does like Lunit do? I'm not familiar with.
Also, Lunit scope looks at the tumor infiltrating lymphocytes. And they can tell you if it's in the tumor or the stroma or they're non-existent. So you can look at the correlation. So you can look, so we, with Cho Hyung-gyu, Dr. Cho Hyung-gyu, we published paper in American Journal of Pathology. To read that paper, I think Park Jong-han is the first author. So you're doing exactly what we did with AJP paper in thyroid. So that will make it much more interesting. That's actually what Dr. Horyun did. He did the same thing in ovarian and endometrial. And for endometrial, he got the oral presentation. So thyroid, we understand it's cold tumor, but it can't be zero. Some people are going to have immune infiltration, and what is so unique about them, and what are their survival outcome, and all that can make that paper come out stronger. Yeah. So you already wrote most of the paper, I know. So why don't you work on that now and and like submit it? So so Liam, you'll be the point of contact. How about email Dr. Oak, ask them that we have a project in thyroid and we treat thyroid cancer patients in our clinic. So can you ask them, is it possible to give us unit scores for the thyroid cohort in the TCGA data set? They already have the whole data set, I know. So ask that question to Dr. Oak, CC me and Dr. Myungwoo and myself, and we'll go from there.
Okay, so I'm just requesting the TCGA data for the thyroid cohort that they have.
No, the Lunit score. Lunit score from that thyroid cohort TCGA data.
In the okay. Sure.
And Myungwoo, you have the DNA and RNA data from the thyroid?
I
DNA,
think
you don't
so,
have
yeah.
the raw data, but
No, not DNA. I think
mutation, curated, yeah, but the RNA data you downloaded, right? So. Okay, so that's a potential. That's something that you have to wrap up, but then once you come, heterogeneity will be kind of your main.
So I wasn't really able to follow current like trends in research, oncologic research. I was thinking I wanted to ask like, is there something related to like liquid biopsy or ctDNA? Because as I was like working in our hospital, it's community hospital, and there were like a lot of drawbacks or delays in getting like biopsies because it's also invasive. Sometimes it's delayed due to our setting. and also a lot of side effects like pneumothorax, especially with the lung biopsy, EBUS versus CT guided biopsies.
So what is your question?
So is there anything ongoing regarding like liquid biopsy or ctDNA study that was I was just curious like about those.
Oh yeah, so that's what we discussed with Stas. We're trying to get the raw file from Guardant and analyze heterogeneity. This is what Choi Jae-yoon started.
Mm.
And how do you assess heterogeneity? There are different ways, methods to do it. And Stas was able to do pi-clone analysis. So we're gonna do that from tissue is from Tempus, and the blood is from the Guardant. So we're gonna look at the heterogeneity and then correlate that with a treatment response, survival outcome. So that's a big project, but it requires a lot of thinking. So yeah, it's intellectually stimulating and a lot of statistical work and understanding what the best way to assess clonality. So I think you'll do well with this type of project. It's not really, yes, no, and just 2x2 table. It's a lot more fun, I would say. So yeah, keep reading about what the best way to assess clonality, heterogeneity, using DNA and RNA, using blood and both tissue. Yeah.
Yep. So I'll try to read about Luni's score till heterogeneity, everything.
Yeah.
While
And Stas wrote a nice paper. It's published. So read that review paper.
Mhm.
That will help you get kind of get it into the right thinking mode.
Okay. Sounds good.
Okay. Great.
And Dr. Nam, could you send me your email address so I can put you in the
okay.
email thread?
Dr. Nam used to be our main journal club person. He has a gift in teaching, so I look forward to your participation. Good. Eileen, welcome.
Hi.
Do you have any
Nice to be
update for
back.
us? What are you doing and all that?
With regards to like lab work, I don't think I have many significant updates, but I guess like going to the missions trip with Dr. Che over winter break was a big and very meaningful experience. Yeah, and I'm glad to be back and start working on stuff again.
Great. I talked to Dr. Iser Kim, but I want you to finish the variant classification project with her. And the immunotherapy related gene variants is the next step. So work on it, and if you want help from other MDs in the lab, or I think people like, from the mission trip, Peter Hasao Kim expressed interest joining our lab. So I let him join online because he's gonna come like 2 months during summer. So you can work with him like you've worked with Grace, because she's busy in medical school. You can assign Peter to do some the tasks that divide and conquer work you've been doing. And then who else? I think that's pretty much it. Yeah, and then you can, as things come up, like you can still work with Lena. Yeah, and we'll have more people in the lab who can help you. But you'll be the undergrad project lead, and Iser Kim will be your mentor to with the project. And Liam, don't forget the pacemaker paper. If you need help with undergrads, we have students coming. So yeah, you can kind of assign them to write it with you. Will be a good opportunity. Yeah.
Yep.
So what
So-
is your main work these days, Eileen? What have you been helping with?
Dr. Liam with the pacemakers paper, and then we like briefly met in fall quarter with Dr. Isid about the variant classification stuff. So
Mm.
just continuing to work on that, and then like the pacemaker video interview stuff.
Good. Keep doing what you're doing. I know Grace Kang is,
Yeah, she talked to me
Okay.
about that too.
and she
Yeah.
wants to join from spring, but she could be involved in any projects that you're working on as well. So feel free
Mhm.
to loop her in to see if she wants to help in any way. I'm
Okay,
as well.
sounds good.
Yeah, and she can join this lab meeting anytime she has no class. So. Okay, anything else before we wrap up our meeting today? No? All right, then we'll wrap up here and we'll talk to you guys later.
Thank you.
Thank you, Dr. Che.
Thank you, Dr. Chen.